Just make yourselves comfortable. We've got 15 people in attendance already. I think there's about 40 odd people booked onto this, so we'll just give it a minute for everyone to join before we get going. Okay, so let's make a start. Other people can join as and when they can make it in. Good morning, everybody. My name's James Cadman. I work for a business called Action Sustainability. We're the company behind the Supply Chain Sustainability School. And we're here today to give you the final webinar module in the LCA Assessor Foundation training program, something that has been developed in collaboration between CIBSE, Construction Carbon, and the Supply Chain School. So welcome. Let me just push on my slides. This is the conclusion of the learning for the LCA Assessor Foundation training program. What you'll have done so far is the 6 modules, the 6 videos that you've gone through. This is the 7th part to that. This is a live webinar session, and it's your opportunity to put questions to our panel of experts, anything that you might have seen or heard in the preceding 6 modules that you think you might want to ask a question about, or any other questions that you might have around whole life carbon assessment of buildings and their components. The whole idea is that it's going to give you the information that you need to finish the course. Beyond the 6 modules you've done already and today's live session, there is a final quiz that has 33 questions in that. That's another resource, a separate resource on the Supply Chain School that you have to go through and undertake the quiz, undertake the test. And if you get 80% or more, you pass, and then you've passed the whole foundational course, and you get a certificate as well as part of that. So really do use today as an opportunity to put any questions, any clarifications that you might have. We've got about an hour and a half in today's session, and it's going to be broken up in terms of me presenting a recap of the 6 modules so far, but also time for you to put those questions to the panelists, which I'll introduce in a minute. Just in terms of those questions, as and when you think of questions, just pop them into the Q&A function within Zoom. Don't hang around until near the end. If you've got a question, just type it up, that's fine. Please use the Q&A chat, pop it in there, and we'll be looking at those, and we'll get around to as many of them as we possibly can in the time that we have. So yes, my name's James Cadman. I've already introduced myself. And just to summarize, the course content that you've seen already was written by these wonderful people that you can see on screen now. Leonardo Poli, Pat Herman, Jane Anderson, and Simon Sturgis with support from Introba. On today's session, we've got Simon and Pat who will be here to answer your questions that you might have. So as I say, do take this opportunity to put those questions to them. Any clarifications that you might have, or anything that you might find ambiguous that you want some further discussion with. So thanks to them for the content and obviously providing the learning to you guys as well. We do like to hear your feedback as well on the course more generally, and today's session as well. There's a link here to a feedback form. We'll put that in the chat so you can access it, and we'll repeat it later on in the session as well. But it's really helpful for us just to get your feedback. If you can spend 2 or 3 minutes, it's as simple as that, to put your feedback and tell us what we do well, tell us where we could do better, usual kind of 360 feedback. It's really helpful. And we'll also feed into the other courses that we're developing as well, for moving beyond a foundational course into a practitioner course. It's only 10 questions. It won't take very long. So we'd really appreciate that in due course. Quick overview of today's agenda. I'm going to give you a quick recap of the 6 modules. This is a recap. This is not giving you new learning. So sit back and absorb the recap, and hopefully it will jog your memory on some of the stuff you've done recently. It is there intentionally just to help cement what we've done and what you've done so far. So if you recognize it all, that's great, because it means you've learned it and you've picked up that knowledge. If there's stuff in there that you're not quite sure about, here's the opportunity to ask those questions. What we're then going to do is have an opportunity for you to put your questions to Simon and Pat in the Q&A, and that'll be a session where you can put your questions in the Q&A section of Zoom, as I've said, and then we can ask those questions live. And then we'll give you some information about the assessment quiz itself, the 33 questions, the assessment quiz that sits on the Supply Chain School website. Okay, and then the feedback, of course. We're going to use Mentimeter throughout today's session. If you've been on any Supply Chain School webinars or Lunch and Learns or virtual conferences, you will have done Mentimeter at some point. So you can grab your phone. For those of you who haven't, it's a bit of online polling software. It's a bit like Kahoot or Slido or any of those that you might have used in other sessions. You can see the instructions on the screen. You simply go to menti.com. It's probably easiest if you use your smartphone because then you're not toggling different tabs on your computer, but you can use it on your computer just the same if you don't have a phone to hand. Go to menti.com. It's best in Chrome if you are on a computer rather than Microsoft Edge. There's a bit of a software thing there, but as I say, if you're on your phone, it's really simple. There's a code there as well, 42 12 68 82. I'm going to toggle my screen in a second, just while you're grabbing your phones and putting in the web address and the number. Importantly, don't disconnect from this Zoom webinar. Stay on the Zoom webinar. They can run in parallel. They are separate pieces of software. So we're going to use this throughout the session for the next hour and a half, just to ask you a few questions. The first one's very simple, just to ease you into it. Who you are and where you live, what your job is basically, and where you live. So let me just toggle over to that. There's the instructions again, menti.com. The code is on the screen. You can use a QR code if you wish. If you are tech savvy and you can get your QR reader out quick enough to take a snapshot. The chat box as well also has the code in it, as well as a link to the feedback form in due course. So the code is in there. I can see people joining. We've got 33 attendees and I can see 12 people are in the Menti already. The code will always remain on the screen, by the way. It's always at the top. If you can see at the top, it says join us at menti.com and use the code. That will always be there. So I'll just give it a few seconds for people to join. Okay, so when it gets to around 20, I'll push on. Okay, let's make a start. Okay, so simply, what is your role and what is your location? So your geographic location, which city you're in, which country are you in? That'd be really nice to know. And you can type your information into the boxes on your screen and then just click submit. As you'll see, you've got 200 characters, so it's like a bit like a tweet, or whatever the new version of a tweet is, an X now. Okay, so lots of people in London, in the UK, excellent. Sustainability people, structural engineers, and energy sustainability, excellent. Super. Singapore, we have international representation. Good evening to you. Hopefully it's not too late in Singapore. Okay, Thailand as well, Prague, okay. Leicestershire, super. Wonderful. Thank you very much. That will still run. I'm going to flick back to the other slides that we've been using, but that will still be live until I push the question on to the next one. So if you're scrabbling around trying to log on or anything, that will still be there on your screen. Thank you for your input. That's really valuable for us to know the kinds of roles that are taking part, the kind of people who are interested in this topic, but also where you're located. That's also good information for us. Super. Okay, so this is where I give you a brief recap of the different modules, going through them one by one, just to kind of give you that revision, I suppose, that recap of where we've been. So the first module, what is embodied carbon and why is it important to sustainable construction? Just a real brief overview of the climate crisis that we're in and why we have a focus on carbon emissions in particular, and of course in the built environment. We all know about the climate crisis. We know about the greenhouse gas effect. That's essentially where the Earth's atmosphere is being thickened in simple terms with more greenhouse gases like carbon dioxide, methane, nitrous oxide. What that's doing is it's trapping more of the sun's heat in and letting less of it escape into space. There is more heat in the system. Sounds like most of you are engineers, so you understand the concept of a closed system or largely closed system, and the energy is being trapped, less of it is getting out. That energy has to go somewhere. It's rising temperatures in the air, in the oceans, and then of course the climate impacts that come as a consequence of more energy in the system that has to be dissipated. We know as well, of course, that there are different gases. I've mentioned 3 of them already, but also the refrigerant gases like HFCs, PFCs, SF6 used in high voltage switchgear, and so on. So there's lots of different greenhouse gases that all have different global warming potentials. They're not all equal. As you might recall, carbon dioxide is notionally 1 in terms of its impact, and everything is done relative to that. So methane is 28 times more impactful than carbon dioxide. Nitrous oxide almost 300 times more impactful, and sulfur hexafluoride is almost 23,000 times more impactful kilo for kilo compared to carbon dioxide. And then it's important for us to consider carbon impacts over the life cycle of a built asset, building. We're not just looking at one particular impact or one particular part of the life cycle. So we're very much looking at the whole life cycle, from extraction, processing, manufacture of materials that will eventually go into a building. Transport is a key part of that as well, in between the different processes, construction on site, obviously, and then commissioned and into the use stage, where it gets used over the lifetime of the asset. That involves refurbishment, remanufacture, repair and maintenance cycles as well, still within the life cycle of the built asset. And then ultimately there'll be an end of life stage somewhere, where parts or the entirety is dismantled, disassembled, and replaced with something else. So we're looking entirely over the life cycle. So that includes kind of the upfront embodied carbon, which is really key in terms of the materials that we're consuming, but then also the operational carbon during the delivery and the lifetime of the asset itself. That includes not just direct energy use, but water consumption as well. And it's really important to consider this when organizations are looking at net zero and their targets for net zero, whether that's for science-based targets or for some other reason. Having this life cycle approach is really important, that we include everything. It's a holistic approach. One key fact here is that embodied carbon has in the past often been forgotten because we're focused on energy efficiency in use, but embodied carbon can be as high as 50–60% of the entire life cycle impact of a building, depending on the nature and use of it, of course. So embodied carbon is increasingly more important. The materials we choose, how we design the buildings that we are putting up ultimately. Rather detailed diagram, but I'm sure you've seen it before. This shows the various life cycle stages according to BSEN 15978, and it's used in the RICS Whole Life Carbon Assessment Standard. Takes you through that life cycle. It's a different interpretation of the image you saw on the previous slide, starting with the modules that begin with A. They're the upfront carbon, and look at the material extraction, the material processing, ultimately forming a final product, which then gets transported to site and is constructed under A4 and A5. So that's kind of up to practical completion of the building, to use that kind of terminology. We then use the building, the asset, of course, and we move into the B modules, where we're directly using the building. So you've got the direct impacts from carbon emissions in B1. So those could be fugitive emissions from HVAC equipment, for example. And then all that repair and maintenance and refurbishment cycle that I talked about a minute or two ago. That's then added to with the direct operational emissions from the asset itself, operational energy, operational water, but also ancillary other operational processes, such as vehicle movements, for example, in B8 and B9. That extends the EN 15978 a bit further than it was originally. Then we have the end of life, of course, disassembly, deconstruction, processing, transport, and disposal of those materials, and then eventually out into those kind of beyond the building's life cycle benefits in Module D. So it is a good representation of how the life cycle of a building or an asset is displayed in terms of carbon impacts, taking you through each of those stages methodically. Okay. The net zero strategy for the UK is well set in law. We have the Net Zero Climate Change Act came into force in 2008, updated in 2019. We as the UK and our territorial emissions have to be net zero by 2050 compared to 1990 levels. The net being the key, the clinching part of that. It's not absolute zero. We have a target to reduce our emissions according to the Paris Climate Change Agreement by 68% by 2030 compared to those 1990 levels. So we've got a nice trajectory coming down. There's an intermediate target as well in 2035 of a 78% reduction. What this means is that we are looking in terms of buildings over generally a 60-year lifespan. So we have to take that into account in what we're modeling against the background of UK policy and legislation. So therefore, it's thinking about not just new build, but retrofit as well. And that's a key part of what we are considering here. And with the building stock we have in the UK, the majority of it is where the retrofit piece comes into play compared to new build. So we need to consider whole life carbon across the whole piece if we're going to hit our net zero targets. Built environment can contribute a huge amount to overall carbon emissions. It's been estimated as somewhere between 30 and 45%, depending on which piece of literature you look at. And that's considering both the upfront embodied carbon of construction and also the in-use operational running of the assets as well. So important that we look at the built environment and all the buildings that we have. So this slide is all about the importance of achieving net zero. The graphs on the right-hand side show forecasted material impact for concrete, steel and timber. The dark black line is the trajectory down that we need to move on to maintain a 1.5 degree maximum warming compared to pre-industrial levels. So the IPCC is the Intergovernmental Panel on Climate Change, Paris Climate Change Agreement fundamentally. So that's the trajectory we need, but not all materials are going to be able to do that as quickly and achieve the same reduction. So it's a combination approach. And you can see concrete, steel and timber have different trajectories depending on the nature of the material, how they're manufactured, where they're sourced from. So this all ties into how we design our assets and how we measure the different impacts of the different material choices we make. Because with better, more advanced materials, but also the design process together, we can achieve that net zero target and the decarbonisation that we need through that kind of process. Okay. So quick splurge there on module 1. We're going to flip back to Mentimeter. I'm going to ask you what stage of a product's life cycle is carbon heavy. I'm going to use 2 product examples here. So grab your phones again. I'm just going to push back to Mentimeter. Oh, sorry. Apologies. I should have asked you another question beforehand. We'll come on to the carbon heavy bit in a second. Could you answer this question first, though, please? Are you a member of an institute? You can do a multiple choice, by the way, because you might be a member of more than one. That's perfectly allowable. Okay. Interesting, there's no one affiliated to REBA in this call, but that's okay. Or CIOB for that matter. Okay, super. Thank you. I'm going to push on to the next question. Do you intend to become an accredited LCA practitioner? Yes, no, not sure yet. Okay. I feel this is like the title race for the Premiership. We've got Liverpool and Man City vying for who's going to come out top. Sadly, it looks like Man City at the moment. Okay, cool. Next question, onto the one that I was planning to do a minute ago. And there's a couple of these, like I say. What life cycle stage of a steel product is carbon heavy? What you should see on your screen is sliders. You can drag the little button left to right as a sliding scale from low to high, or from 0 to 100 in effect. Just a reminder as well, while you're doing this question, if you do have any thoughts or clarifications or questions for our panelists, please do put them in the Q&A, and we'll get to as many of those as possible. Okay, so material extraction and manufacturing are coming out highest here. Transportation has got a fair amount. I suppose that depends on how far it's traveling, of course, and by what mode. Okay, so when we get to the Q&A, we can maybe comment on these and a reflection back from Pat and Simon on those outcomes. Okay. And then the second one, same question, but for timber this time. I think for like many of these materials, the answer could be it depends on so many things, and it does clearly. Depends on how you manufacture it, where you manufacture it, what the energy is that you're using. Is it grid electric? Is it fossil fuel? Is it something different? Is it renewable? How is it transported? How far is it coming? And then what happens to it at the end of life? How is it disposed of? How is it recycled? How is it recovered? So maybe, like I say, that's something that we can pick up a little bit later. Okay, super. Thank you very much. Okay, on to the next bit, module 2, life cycle assessment deep dive. So we've already seen this in a previous slide, the pictorial representation of BSEN 15978 as it tracks through from A1 out to the D module. We've highlighted here the A module, and what you've got is just a logical progression, as you might expect. A1 is raw material extraction, so that could be from a quarry, it could be from, if it's a biological, biogenic material, it could be from a forest or from a crop. It could be harvested in different ways. It could be from mining, for example. There's always going to be transport, several transport stages. So this is a bit of a simplification. There's probably more than one transport stage, depending on the complexity and the supply chain route that you have. A3 is manufacturing and fabrication. So then again, that's going to be very complicated, depending on how many steps go in that supply chain between raw material, basic product, something a bit more complicated, and then getting components and manufacturing them. More transport, of course, the final transport leg of that completed product to the construction site. And then A5 is the construction and installation on site, using plant and equipment and other means. There's different ways of describing how much data we're including. And some of these are trademarked titles, but they basically make sense, and they just give that shortcut to understanding what it is we're trying to describe. So a cradle to gate takes in A1, A2, and A3. So that's really the manufacturing. That's the supply chain, producing a product and then selling it to the contractor, to the designer, whoever's going to ultimately install it on site. So that's known as cradle to gate, the manufacturing gate. Then you get cradle to practical completion, which is very much a construction sector terminology, the practical completion of that building and asset when it's commissioned and handed back to the client. And then we get much further out, we get cradle to grave, which includes the life cycle of the asset. So through its life cycle. Could be 60 years according to the RIC standard. Certainly in housing, that's what's used there. It might be different depending on the situation. And that end of life stage when it is dismantled, recovered, transported, and disposed of. And then finally, if we use the benefits, the module D, those benefits that occur out beyond the boundary of the building itself, those recycling benefits that can be accounted for and allocated. Okay. There are lots of different kinds of data that we can use and we can gather. We won't always get the perfect data that we need. We can get two main kinds of data. Generic data that is industry averages, it's sector averages, it's not relevant or specific to that manufacturer of a particular product. And then conversely, of course, the flip side to that is specific data that's relevant to a given product or maybe even a manufacturer. So even within that, there's very specific data for that actual product, or it might be specific data to a manufacturer, but across a range of their products. So it still might be an average, but at least you know it's from that actual manufacturer. So there's different grades of how detailed or how accurate or how specific the data will be that you can get from your suppliers, from your different sources. And here's a bit of an exemplification of it with environmental product declarations. You can get those different shades of accuracy and specificity depending on what the manufacturer can do, what they can provide. A product specific EPD for very much, like I say, just that product, then something across a range, and then you might get a generic EPD. So for example, in the brick manufacturing world, there's a generic EPD from the Brick Development Association that encompasses all brick manufacturers in the UK. Some of them are now looking at doing their own product specific EPDs, but for a long while, that sector has had a generic EPD for all bricks manufactured in the UK, which is better than nothing, but of course it doesn't give you the specificity and the detail that you need for the specific brick in this case that you are looking to use. Many of these pieces of data are available in various data sets and databases. The one that most people talk about is the Bath Inventory of Carbon and Energy, the Bath ICE database. There's also, of course, now the Built Environment Carbon Database, which has been created through the collaboration of many organisations, including RICS, REBA, CIOB, Bath as well, to give that consistency in where we go for information on EPDs. There are others out there as well. EC3 is another one that's available, largely US oriented, but it's another source of freely available information on product EPDs. And then, of course, you can look more widely. You can search more widely through the literature. Okay, this piece is about scenarios. They play an important role in LCA results, especially in the early stages. So as you're working through the different design stages for a building or an asset, you're going to start with fairly generic high-level data in simple terms. And as you go through, you're going to get more and more accurate, more specific data as you go through. Any of you who use the REBA plan of works, working through the different stages there, will recognize this concept of getting an idea, getting a scope, and then refining it and making it more accurate as you go through. And you can see in the image here, whether it's early design phase, technical design or construction, and then the post-completion, you get more accurate, more specific data as you actually home in on the real products that are being used, the real elements and components that are being installed in the building itself. You'll start off with predicted values based on some generic data. And as you design that and qualify, yes, we're going to use this kind of material from this supplier, you can get more accurate data. So the idea is to narrow in on what the outcome will be. And obviously post-occupancy, you can get into the use phase as well. Rather than just model data on kilowatt hours per square meter, for example, you can get into real data as the building is actually occupied and being operated. The as-built values rather than the previous values on design. Okay. Super. We're going to jump into module 3, which is about EPDs, a bit more on that, and get you thinking about some of those things as well. So an EPD, an environmental product declaration. transparently reports objective and third-party verified data about a product or service's environmental performances quantified from life cycle assessment. It is more than just carbon and climate change. They cover a lot more than that, but they are very much the environmental aspect of a product or a material or a service. Very useful in many different situations, not only to understand the carbon impacts, but it helps in many other ways as well. So ones that we're involved in quite a lot is when it comes to tendering and procurement. EPDs are a very useful tool in helping understand different material choices. This is a snapshot of what they might look like. Here's one from BRE that describes what they cover. They're fairly short and concise documents, easy to get your head around once you've seen a few of them. And they cover the same kind of approach. It's a template that's used to provide the information. Which life cycle assessment standards are used, what product category rules are used in the calculations, and PCR's product category rules describe how you assess particular kinds of products. It gives the boundaries and the approach to assessing the environmental impacts of that kind of product. Those product category rules are agreed by relevant experts to give that consistency. The whole point, of course, is consistency and comparability between products. The EPD will also give you the date of issue and the expiry. It's often 5 years in terms of how long they are valid for. That's the usual time that we have seen. Who has actually conducted the EPD on behalf of the organization manufacturing or looking for the EPD. And then there's verification to give the robustness and credibility to the EPD itself. Within an EPD, you'll always be able to see the functional unit. And that's the basic denominator in effect to be able to compare this product versus that product. You're comparing them on a like-for-like basis. It's the whole apples and pears discussion. Are you comparing like for like? So in the brick example I talked about a few minutes ago, the functional unit there is a ton of bricks. So it's not a number of bricks because they have different sizes. It's a ton of bricks is the functional unit, and you compare them like for like. It talks about the EPD type, so whether it's cradle to gate, cradle to grave, or some combination thereof. So again, you can see how much is included, what are the boundaries of the EPD, what data is in and what data is not in. And then also the background databases that are used for the conversion. So you've got your activity data, so how much energy was consumed, how much waste was produced, that kind of primary activity data, but also the database, the conversion factors that were used, and how they stack up in terms of their product specificity to the previous few slides. Are they product specific or are they more generic? The EPD will also show how the product is made and how it's used in a building. So it'll give you a nice diagram to take you through where the product was manufactured, how it's transported, how it's used, how it's disposed of, basically a pictorial version of its life cycle. And the key technical information for the characteristics of the product, how it was manufactured, and again, how it was used. So it provides all that raw material information, and on the right-hand side, you won't be able to read the detail. Don't worry, you're not meant to, but it takes you through the different life cycle stages of the product from A1 all the way out to the C module, C4 for waste. And it also, where applicable, provides information on the D module, so the outside of scopes impact. And it provides that across a range of different impacts. So global warming potential, eutrophication potential, acidification potential, other life cycle indicators as well. And it provides you that detail so you know which ones have been included within the scope as relevant. Another one on there is ozone depletion potential. Cool, okay. So here we've got the same image that you've seen already in terms of the different life cycle stages from the A modules through B, C, and D. And this is based on the relevant standard for EPD. So that's EN 15804, which derives down from the wider life cycle environmental impact of a building, the other standard 15978. And this module, sorry, this standard was updated in 29 and shows the different aspects that are mandatory and those that are optional as well. Excuse me, just while I find my cursor. There we go. Sorry, I'd lost my cursor on the screen there. So you can see that there are different levels which are mandatory and those which are optional. We always need to include the production stage of the material. That goes without saying. And depending on the kind of output that you want to do, whether it's cradle to gate or cradle to grave, there are various different parts that you need to include. And it kind of makes sense. If you're going to do cradle to grave, module D, everything is mandatory, because you can't do cradle to grave A, B, C without doing end of life, for example, module C. It goes without saying. So it kind of makes logical sense here. If you're just going to do cradle to gate because you're a manufacturer and you don't know how that product's going to get used, you can only use modeling, for example, and scenario analysis. It makes sense just to do cradle to gate for your material A1, 2, and 3. Okay. Allocation is a very important part of life cycle assessment methods here. And this is all about when someone is manufacturing a product, but they get a co-product. So we're not talking about wastes here and residues. That's dealt with in terms of waste management, and whether that's recycled, whether it's composted, whether it's landfilled, or energy from recovery, other routes there, energy from waste recovery. So this is about co-production processes here, and it's two different ways of allocating the environmental impacts of those products, the product and the co-product, based on two different methods. You can do it on physical properties, so the mass, the kilos, the volume, the liters, when the difference in the revenue from the co-product is low, when it's less than 25%. So if it's a co-product that you will get some revenue from, but it's relatively minor, it's relatively insignificant. It's not the point of what you're doing, basically. So therefore, you just allocate based on mass or volume, those physical properties. But when the difference in revenue is greater than 25%, allocation should be based on the economic values here. So there's a couple of examples on the screen here. If one co-product generates £1 million revenue and the other one 1.1, you allocate it by mass. So they are important there. So the difference is relatively low. But if the co-product generates 1 million and the other one generates 1.5 million, we allocate it by value, because there's a difference in scale there. So it's just thinking about remembering that there are those different approaches to allocation between co-products, depending on, as I say, whether a co-product is valuable enough or less so. Okay. So using EPDs and their comparisons should generally always happen at the building level to ensure that all knock-on effects are included. The ripple effect of choosing one material versus another will have knock-on effects to the rest of the design, and making sure that those are captured. Also think about the inherent uncertainty within EPDs, based again on what we showed earlier, whether it's a specific EPD or more generic EPD, depending on the level of accuracy or the specificity within them. There's always going to be some level of uncertainty. Any life cycle assessment study will have an element of aspects that are not included because there's no data for them, or we're not sure about the data. So there's always going to be that level of uncertainty, those error bars around what we are looking at. We still need to be wary of differences between the functional units. Ideally, they should be comparable. That's kind of the point. But think about checking those and making sure they truly are comparable as much as possible, and the scenarios likewise that we talk about. And there are other differences and variations as well, different background data, different product category rules, different databases that we might use. So Eco Platform is the umbrella organization for construction EPDs. It provides this open and transparent and credible construction LCA data. Very useful to have that comparability. That's one place to go to provide the data that's needed, because we want to have more harmonization and more consistency with what we're doing, particularly when we come to reporting, and then that knocks on into other things, such as ultimately CSRD, for those of you who might be involved in that, science-based targets. Other reporting mechanisms will ultimately be pulling on some of this kind of data. So having that harmonization and ability to verify is really important. Okay, back to Mentimeter for another question. What are EPDs used for? If I push back. Any of you who've been kicked out inadvertently, the code is always at the top of the screen, 42126882. Sometimes Menti does that on some people's phones. Don't know why. Glitch in the matrix. What are EPDs used for? And this is a ranking question. So what's the primary reason, the secondary and the tertiary reason, in your view, for EPDs? Okay, that's fairly clear. Environmental impact, so we know what the numbers are. And then the use of that, I think personally it's very useful to be able to take that information and apply it somewhere. So it's not just a case of we know it's so many kilos or so many tons of CO2 equivalent, but also to use that in terms of comparing different products, whether that's in a procurement or a design or a different stage of the building's life cycle. And there's some regulatory compliance as well. Okay, super. Thank you very much. Okay. Module 4, we're over halfway through, we're zipping through. Materials, getting into that one now, just to give you the recap of what that was about. There's some key strategies that we can deploy for low carbon building design and kind of 5 crucial aspects that we need to think about. Can we choose low carbon materials? There's something called the energy and carbon hierarchy, which is a bit like the waste hierarchy. So I'm sure you're all aware of avoid, reduce, reuse, recycle, recover, and then ultimately dispose. Same kind of principle within carbon and energy. There's a hierarchy there about avoiding energy use where possible, being efficient with the energy that we do consume, switching to lower carbon materials, lower embodied carbon where possible, and ultimately renewable sources of energy. Same kind of mindset there in terms of reducing our carbon emissions. And this is what's displayed here in terms of some of the key things that we can do, thinking about materials that are inherently going to give the same functional output, but they have a lower embodied carbon, whether they're bio-based, whether they have recycled content, their modularity, and the ability to swap them out where possible. There's also just direct energy efficiency. So having a design that allows for lower consumption of energy. So that's using materials to insulate buildings better in simple terms, using passive design techniques, whether that's natural lighting, natural heating as well. So we just avoid the use of energy in the first place, or we minimize it compared to what we might otherwise do with mechanical ventilation and heating, or obviously lighting as well. And then importantly, the non-regulated energy use in terms of the energy efficiency of the devices that we might use, how we can install more energy efficient equipment as well. Durability kind of makes sense. If it can last longer, you're extending the lifetime of the product. You are not replacing it and therefore creating more embodied carbon impact from a replacement. Making sure that they are modular and you can adapt their use. Future proofing is a bit of a buzz phrase for that. Can that element or that part of a building be adapted for future uses? Can it be maintained well? So we're looking here at the B module of EN 15978, the repair, maintenance, refurb stages and modules. Can we reduce those impacts as well through better durability because we're improving maintenance? And then considering end of life as well, making sure that that when it does come to the end of life, we can disassemble it, we can recycle it effectively. This is all about eco-design, so that materials can be pulled apart more easily to allow for recycling. They're not complicated multi-laminate products that can essentially only be disposed of rather than being recycled because it's economically prohibitive. So thinking about all of these eco-design aspects across the life cycle of a building or an asset, but also predominantly in the design, what materials we're going to use and how is it going to impact on these different aspects here. And then that will naturally roll into engaging with suppliers and procurement. So here it's about being realistic. It's about being relevant and understanding what we're trying to achieve that is actually achievable. So it's challenging but achievable, that we can do what we need to do without hyping things up, as it says on the slide. So making sure that we're focusing on the right things, that we're focusing on the priorities. There are some hyped things, some sexy things that that some people like to install or suggest for buildings and assets. Are they really material? Are they significant when it comes to carbon emissions? So it's understanding the relevance, the priority, the significance of those key issues that we need to look at. You know, it's getting into those carbon intensive materials, the concrete, the steel, some of the other materials that we consume, and focusing on those rather than just the window dressing, so to speak. We need to understand, of course, the baseline. What are we trying to achieve compared to a business as usual model? How much can we achieve? What savings can we actually achieve through that? And making good, clear comparisons, reasonable comparisons with what would have happened otherwise had we not undertaken this kind of design for carbon reduction process. So avoiding the risk of having misleading metrics ultimately, and misleading outcomes. And ultimately, what value are we trying to add to this? Getting a number, getting data accuracy is great, but that's only one part of the conversation. What are we trying to achieve because of that? The number in itself is a kind of tool, as a stepping stone towards a bigger conversation about energy efficiency, reduced carbon, and so on. So it's making sure that we look for accurate data, but we don't waste too much time fundamentally in the resources that go with it, chasing the ultimate fifth decimal point in what we're trying to achieve. There's a bit of a Pareto analysis here, an 80-20. We need to make sure that we get good quality data as much as possible, but that's not the end of itself. We need to make sure we understand what we're trying to use that data for, and that's the value add piece as well. Okay. What we're looking at here is the different kind of tools that we can use to check a model for its accuracy. What we can employ to get that ideal accuracy without going to the fifth decimal place, and making sure that we have a reasonable representation of what we're trying to actually deliver here. You see on the screen, it's understanding that the data is reliable and credible and robust as much as possible, because a decision is going to be made from that, whether that's a procurement decision, design decision, it's meeting policy requirements. There might be some legislative compliance at some point as well further down the line, particularly if you're looking at, in the UK, streamlined energy carbon reporting. That affects module B6 clearly in the standard. So how we're going to make sure we've got the accurate data. In terms of the data set that we're using, the activity data, but also the conversion factors, the emission factors, are they representative of the geography we're in? So for example, are we using EPDs that are representative of materials that are manufactured in the UK or Europe rather than, let's say, in the US? There will be differences there. The most obvious there is the grid electricity mix, but other aspects as well will play into that, not least transport. Are they representative in a time perspective? Is it up to date fundamentally, or is it information that is well out of date that is being used? I'll give one example there. I was working with a client and they had some conversion factor data that was from the USA, and it was from 20 years ago. It was in the built environment, but it was 20 years old and it's from the US. So its representativeness, both in terms of time and geography to the UK today, is a little bit sketchy, to say the least. But it was the only data they had, so that's what they went with. But understanding those issues is crucial, and being able to communicate the output of an LCA, of a impact assessment of a built environment project. And the benefits you can see there clearly on the screen: improved data quality, reduced uncertainty, enhanced transparency, and I'd say as well enhanced reputation. Cool. We also need to consider decarbonising the grid, the future outlook for the UK's grid mix. For those of you dialing in from Singapore, Thailand, Czech Republic and other places, you'll obviously have your own grid decarbonisation pathways for your respective countries. In the UK, we are on course to decarbonise our grid largely by the year 2035. There'll still be a little bit in there, but it's coming down very significantly. It's come down at least 2/3 in its carbon intensity since 1990 because we've moved away from coal pretty much. There's still a little bit, but largely away from coal. We now have about a third of our grid mix is from natural gas, and it's increasingly getting displaced by renewables and nuclear as well. That's coming back more on stream over the next couple of decades. But we have that trajectory as published by the Committee for Climate Change to decarbonise by 2035. So taking that into account is important as well, because some of the carbon targets and reductions will be happening inherently. That's both for the supply of the materials, where they consume electricity, and the manufacture and even distribution ultimately of the materials and products that you might be using. But obviously, most importantly, in the use phase, in the B modules of the life cycle of the asset as well, operational electricity will come down, particularly as well as we switch away from natural gas as a source of space heating and even hot water heating and move to more electrically powered devices such as heat pumps. Electricity takes on a bigger role. So it's thinking about some of those different strategies and how we can build that into the designs of what we're doing. And the call to action is quite simple: integrate that decarb trajectory. It's the net zero pathway for the electricity power sector in the UK. That's what it's described as. Build that into your net zero strategies, because that's going to be going along in the background anyway. And then there's thinking about optimizing different building elements. Something I touched upon earlier was, let's focus on the key issues for carbon. Let's avoid the hype where possible. Different things, roof mounted this and wall mounted that, those are great, but are they really going to actually contribute loads to carbon reduction? They'll have other benefits. They might have well-being benefits, biodiversity benefits, particularly in many cases. But in terms of direct carbon impact for the buildings, let's focus on those key elements. And you can see the 5 key elements here in terms of facades, foundations, shell and core, the walls, roofs and floors, and windows. And it's looking at that holistic approach about how these different elements all interact and how we can optimize them together in terms of the energy efficiency and the reduced carbon between them. So again, it's about low carbon materials, inherently less embodied carbon, whether it's recycled content or whether it's just fundamentally a different material that is being used. It's thinking about bio-based materials, whether timber's a possibility, for the structure, other bio-based materials in insulation. There's thinking about ultimately efficient heating appliances within the fabric of the building as well. And similarly, windows is an obvious one in terms of insulation values. It's those U values, optimizing those as much as possible. And things like solar gain to improve natural light and natural heating that can come from the sun directly. So it's thinking about the combination of those and how they can optimize the energy efficiency, the carbon efficiency of the asset that you are looking to design and build. Okay, I'm just going to check notes here. Yes, you'll see in the chat a request again if you've got any questions. Please pop those in the Q&A. I can't stress enough that this is your opportunity to ask that question. No question is a silly question. I'm going to move on to module 5, which is an overview of the international standards in this space. I'll take you through that. There are various international standards. The International Standards Organization and the European Norms Committee provide all of the standards, many of the standards that we are talking about and are relevant here, and they all interact in some shape or form, as well as national standards like British standards, for example. We have various different committees that operate in developing the standards with nominated experts who sit on mirror committees that are organised by the national standards body. So in the UK, that's BSI, British Standards Institute. And that brings in experts and professional bodies from across the sector. Who's got that knowledge, who's got that experience to really hone in on what a standard needs to cover and how we describe it in a way that's unambiguous, and is communicable to those who are going to use it. Drafting standards involves various committees, and they do various versions. So one of the standards that we've personally been involved in as our organisation was around sustainable procurement. And on the ISO stage, the international stage, from inception to end, it took about 3 years, various drafting committees globally from various participating nations to get involved, and then take the comments from the mirror committees as they go through the drafting process and ultimately out to voting and publishing that standard. Every standard has a 5-year review cycle. Things change, technologies move on, ways of working move on. So there has to be a natural 5-year cycle. So a plan, do, check, act, if you speak ISO 14001, that's a very important part of this as well. Here's a table that compares international standards, European standards, and British standards. For our overseas colleagues, you'll have your own standards institute within your country that you can relate this to. And you can see that some standards are all three. They're international, European, and British, such as 14001. That's a really truly global standard, probably the most prevalent. Certainly in the UK, it's the most popular standard. ISO 14001 alongside ISO 9001 for quality. You'll get some which are one or the other. So with the European standards, the one that we've been looking at, 15978, in terms of the environmental impact of buildings and assets, is a British standard and a European norm. And you can see the description there in terms of how they are developed, who's involved in terms of the acceptance, the developing committees, and who's involved in drafting them and providing comments. So it's quite a complicated picture, but the idea here is all about harmonization as much as possible. Okay, there's some key language here that I won't spend too much time on, but it's the key description. You'll see this in legal documents a lot as well, in terms of shall, should, may, and can. For native English speakers, even for us, it's a little bit of, oh yeah, that's exactly what that word means, in terms of what the standard is telling you to do. So a shall statement, you have to do it. It's a requirement. Should is recommended that you do something. May means that you are able to do it. You are permitted to do it, but you don't have to. And can is that you are able to do it. You can do it as well. So it's just understanding some of the language. This is normally described in the standards as well, just to amplify that. Okay, some of the key standards that we have, we've touched upon many of these already through the course of this process. Product level assessments, the main one there is BSEN 15804. That's the one that describes environmental product declarations, gives the core rules and the product categories for construction products. It's very much focused on the built environment, and that's what describes how an EPD works and how to use it. Another one I'm going to highlight there is CIBSE TM65. There's a standard there that talks about the embodied carbon of building services, so primarily mechanical, electrical, and plumbing, MEP. Gives you a calculation methodology of how to estimate and calculate the embodied carbon of those different services. And it has different levels depending on the amount of data that you have to hand, whether it's generic data, whether it's product-specific data or not. There's 2 or 3 levels within that standard to allow you to estimate with margins of error what the embodied carbon is of those building services, as I say, MEP. The building level 1 that we've looked at extensively already, EN 15978, that gives the environmental performance of buildings. It's the calculation methodology. It's the one that's described in the picture we've seen several times of A1 through to D in terms of the modules. And then importantly, based off that is the RICS professional statement of whole life carbon, now in its 2nd version that came out at the end of last year based on the previous version from 2017. And that gives a methodology, very building specific, based on those BSEN standards that I've just mentioned. It gives you the overview of how to go about that, again, in a consistent and comparable fashion. There are some others in there as well. In terms of net zero, there is actually a definition of what net zero is from the International Standards Organization. That one is free to download. Most standards, of course, you have to pay for, but that one is free to access. That gives guidelines. So it's not really truly a standard, but it gives guidelines on what net zero means. Fundamentally, you need to look across the whole life cycle of a product or a building, the whole end-to-end value chain of an organization, if you're looking at it on an organizational basis, rather than just a narrower scope. So it's really taking in the whole life cycle of that approach. And also having the ambition to reduce carbon in line with the Paris Climate Change Agreement. So those small graphs I showed earlier of steel, timber and concrete with the black line, IPCC 1.5 degrees, the ambition, as they call it, to reduce carbon emissions has to be in line with that black curve, the 1.5 degree curve. And the last one I'll highlight here is PAS 2080, a standard, a UK publicly available specification on the carbon impact of infrastructure and buildings, a way of providing a management structure. So it's not telling you the detail of how to measure the carbon, but it's talking about the management structure that you need to assess your carbon. So what's the leadership? Do you have baseline? What's your engagement? Where does your building sit within a kind of an asset and a network system approach? So it's very much more about the management approach rather than the actual how you calculate it. And then this kind of exemplifies this and how they compare to each other. EN 15978 compared to RICS. 15978 goes up to, focusing on the B modules there, goes up to B7, operational water. RICS and PAS 2080, 2023 version, extend that out to B8 and B9. So that's additional carbon impacts in the use of a building or an asset. And as I mentioned earlier, that could be vehicle movements, for example, that are outside the building itself, but they're very much part of the operation of the building. So you can imagine a facilities management organization having vehicles, vans going around different sites doing maintenance jobs. The impact of those vehicles is inherently part of the operation of the building. That would be an example here. So here's a brief summary of how sustainable construction standards are referenced to in legislation. Different countries take slightly different approaches. So it's being aware of that, whether a building must take a building level assessment or not, whether it's a whole life carbon assessment, whether they need to register EPDs or not, and how those EPDs are used. So there are variations. This is important for those of you who operate across different nationalities, that there are subtle differences. Even though we have a standard or various standards to deliver this, we have to be aware, of course, of how they are delivered in different countries. Okay, last module, module 6, the wider case for sustainable construction. Okay, so let me just move my mouse back here. This is a kind of a 101 on sustainable development. We're looking at here the people, planet, profit, environment, social, and economic. Profits, planet and people is the, as I say, the other way of describing that. We need to get that balance. We can't just focus on one or the other. It's really crucial. This all started off with the Brundtland definition of sustainable development back in 1987. Seems a lifetime ago now, but it's that making sure that we take into account not just the environmental impact, but also the impact on people, and also to make sure that the economy and society is maintained as well. There's no point doing the most environmental thing if it adversely affects people for obvious reasons, but also the economy. If that business goes bust, then you've achieved nothing. So we need to get that balance. There are various different movements, initiatives, programs around sustainable development. Some of them are described here on the slide. One of the most prevalent is the UN Sustainable Development Goals from the United Nations, the UN SDGs. There's 17 of them. They cover the whole of the people, planet, profit spectrum. So it talks about climate and carbon, obviously, but it also talks about impact on environment. It talks about biodiversity, and importantly talks about the impact on people as well. The first one is there, no poverty, and no hunger is the second one. So lots of these are being enshrined into business approaches, and it'd be ideal for building design and use and operation to be tied into this kind of approach as well at an organizational level. When a company comes along to design and construct a new building or asset, that they are thinking about linking to how that design and that construction links into the UN SDGs. Where's the wider global pull for that? And there's various other things out there as well. The one I'm going to just quickly focus on there is the penultimate bullet, the principles for responsible investment, the PRIs. These are provided by private equity houses, organizations that invest financial capital into organizations. They have some ethical investment criteria on how they do that. And there's a growing demand from that kind of investment to have sustainability embedded and baked into what is done. That has grown in prevalence over the last 10 years. It's culminating now in legislation such as the CSRD in Europe, the Sustainability Reporting Directive. That's what the SRD stands for. The UK is going to do something very similar in due course. So that demand for financial transparency when it comes to climate change impacts. The UK's legal targets on climate change, I've already touched upon these. We have the Climate Change Act to be net zero by 2050. As I said, that came in 2019. It was updated from the 2008 version. We've got a 78% reduction by 2035 compared to a baseline of 1990. And we've got a 68% reduction by 2030, again to that 1990 baseline. The 68% reduction is our nationally determined contribution that we've agreed to through the Paris Climate Change Agreement process. These are all just waymarkers, milestones on the trajectory down to net zero. But we've got various stages, as I say, to follow through as a country. There's another way of describing people, planet, profit, and that's ESG. That's the buzzword now. It was CSR a few years ago. They've changed the letters. It's now ESG. Largely speaking, broadly speaking, it's the same thing. You've got environment, social, and governance. Lots of organizations, particularly the investment community I've mentioned already, focus on ESG. What are the environmental impacts, the social impacts, and the governance, the economic stability and the ethics of the organization or project that you're conducting. And you can see the various different things in there. There's no surprises there. It's not that radically different from the sustainable development approach here, but really crucial in understanding the risks and opportunities within an organization or a project. And what they often do is something called double materiality. They look at those impacts in two directions. They look at the impacts from the organization or the project out onto the wider world. That's called inside out. And they look at the financial impacts of what's happening globally on the organization or the project that you're looking to develop. That's called the outside in. So if there was a huge drought or huge flooding somewhere in the world, how would that impact on your business in terms of supply chain availability, for example? And then the section 4 talks about the World Business Council for Sustainable Development and the Construction Innovation Hub. Again, different ways of looking at those impacts. We have the natural impacts, which is the E of ESG. The S of ESG is there with the social as well, and the human part of it as well. And then the governance piece, making sure that we are being holistic in what we need to do. The Construction Innovation Hub looks at the idea of capital in addition to money. So you have natural capital in terms of the ecosystem services we have from air and water, and then produced man-made capital such as resilience and security. So all these different capitals that we can build upon beyond just financial capital. Okay. I think the final Menti question, we'll just flip over to that one. What do you consider of most value when conducting LCA assessments? I'll just push the question on there. Again, this is a ranking question. The code is at the top still, should you need that. So ranking, what do you consider the most value when you conduct an LCA assessment, or when someone does that on your behalf if you don't do it yourself? just while you're answering that question, folks, we're moving close to the Q&A session. We've got a couple of questions in here around targets and aspirations for new builds, retrofits to adhere to net zero. There's something there about building alterations, and there's another question about the best approach for countries that don't have much certified material available. So we'll get onto those a bit. So if you have any more questions, do pop those in the Q&A. In terms of the Menti, identifying carbon hotspots, yeah, definitely. That kind of makes sense. It's what they do. It's the whole point of them, is where the hotspots are. But then I think some of those other options just naturally flow from that. Where's the eco-innovation? Where do we focus our effort and our money and our time in terms of those carbon hotspots? It gives us the route map in terms of where we need to go next. And ideally, if we can bring cost reduction opportunities along the way, then perfect. Super. Great, thank you very much. So we're now going to move into the Q&A. I'm going to ask Pat and Simon if they could turn their cameras on, please. Super. So, great. I think, Simon, you're going to do the first question, were you? And Pat, you were going to pick up the second one?
Sure. If Pat wants to come in after me, that'd be great as well. Yeah, I think this is an interesting question, which comes up quite often. The problem with a new build, because everything's new, it is possible to create benchmarks and targets and so on. With refurbishment or changes to a building, it's much more difficult because the scopes are different, building project by project. However, I think that if you focus on the content of what you're doing from the sort of EPD point of view, that may be the best way to do it. If you ensure that the products you're using have the lowest carbon impact. Obviously, across a project, if you're doing a whole range of works to a building, then collectively those can be given a square meter rate, i.e. the carbon cost against the area. And that will tell you how your building performs in relation to other buildings, whether they're new build or retrofit. But in a way, that's not hugely helpful, apart from showing you, the level at which you're operating. But clearly, for example, if you give a building a lick of paint, you will have a very low carbon footprint for that. But it doesn't necessarily mean it's a good scheme, because of course, if it's just a lick of paint, you're going to have to come back and do it again in a few years' time.
Pat, anything you want to follow up on that?
No, there is, if you can match your scope to some of the existing benchmarks out there that categorize the full breakdown of the impact. So you could look at superstructure standalone, finishes standalone, external work standalone. If your scope happens to match what's included in that scope, then you've got a benchmark out there. Net zero standard is going to have more transparency around what contributes to those benchmarks. But yeah, echo what Simon says, that the best bet is just to look at what you're planning and see where it can be improved and what materials are available that offer a better result.
Yeah. Okay, cool. So essentially what the modules have been talking about. There's a second question here. I think, yeah, Pat, you were going to pick that one up.
Yeah.
Lack of available certified material.
So the question is specifically around countries that might have a lack of available EPD data. Actually, most countries don't have all the available EPD data that we would like. I mean, in the UK, there's a couple of 300 EPDs or something. And there's about a million different materials that get used or more. So everywhere there's a lack of available data, and it's about finding the nearest match always. Better to model something than nothing, and think about the uncertainties in that data that you have available. If the nearest match is a proxy, or it's using a global generic data set rather than product specific. Then looking at the contingency factors that you might need to add in. RICS, latest update to RICS has references for things that you can use there. There's other quality assessments that you can apply and accept that there's more uncertainty in the results and the conclusions that you might be drawing from it.
Super. Thanks, Pat. Lucy, did you have any other questions that you have gathered?
Yes, we've had another one come in. It might be one that would be helpful for Pat and Simon to put anything in the chat as well. But the question is there any additional resources you would recommend for reading, particularly around EPDs and standards, which are not as heavily utilized in structural engineering, for example? So I'll put that to Pat initially, and then Simon can jump in after.
So we mentioned Eco Platform in the in module 3, and that has got a wealth of information on around EPDs, and it's independent information as well. So yeah, it's the umbrella organization for all EPD programs. So what's being produced there is very reliable, and it's what all EPD programs should be trying to adhere to. So yeah, lots of content on there, full digital database of lots of EPDs available. That would be my first point of call, and I guess also the follow-up to this training session where we'll go into more detail on EPDs.
I think if I could add, I think I would agree with Pat completely. I think Jane Anderson, who was one of the authors of the training of this course, has written her PhD. In fact, is on EPDs, and if you can get a copy of that, her website is Construction LCA, and if you Google that and have a look for that. But she has written a kind of, I suppose, a definitive work on LCAs, sorry, EPDs.
She's also written a few briefing papers, which are a bit more lighter touch, I guess, the PhD for Construction Products Association, and exactly. They're all quite useful as well. I'll put a link to those in the chat.
Thanks, Pat. We've just had another question come in as well. There have been varying benchmarks by various organisations such as LETI, GLA, the UK Net Zero Carbon Building Standard, and BECD. I believe these benchmarks were based on old data that have lower confidence. How can we trust a benchmark with higher confidence and is followed by industry-wide? Will that be in the Net Zero Standard?
Shall I have a go at that? I think this is an interesting question. I think the the new RICS second edition methodology is capturing assessments slightly more accurately than the previous version 1, and that's having the effect of pushing numbers up a little bit. But that is, and indeed, part of that would be that in the RICS document there is a contingency allowance, which I won't try and explain now, but it's made up of various components, and that contingency tends to get used rather like a financial contingency. It looks like an extra to start with, but it ends up getting spent, and the same seems to apply with carbon contingency that we've now introduced. So I think at the moment the thinking is to leave the benchmarks where they are. Although I would agree that if you've got a benchmark figure of, say, 533 kilograms of CO2, that's obviously optimistically accurate. But I think with things like the BECD, the Built Environment Carbon Database, collecting data, I think the idea of getting more consistency in data will appear over time with A, greater use of the new version of the RICS document, and B, collection of data. So I think it's an evolving process. And hopefully the UK Net Zero Carbon Building Standard will also help define this more specifically, because one point worth making, the RICS document is a methodology. It's not a statement of what you should achieve. So it's not trying to say you should achieve this level or that level. It's just saying this is how you calculate it. We've left it to people like UK Zero Carbon Building Standard or the GLA or whoever to actually define levels that you should and targets.
There's one more question that's just come in about retrofitting old buildings, whether it's housing or offices. Is it considerably more expensive to use certified EPD materials for the construction regarding HVAC and so on insulation than non-certified?
No. An EPD costs a few grand sometimes, maximum sort of 7 or 8 grand to do. Think of that in the context of how much it costs to produce the products, how many they sell, then yeah, it's negligible. There's no correlation between the cost of a product and whether they have an EPD or not, as far as I'm concerned.
Yeah, I would support that answer.
Super, cool. Lucinda, are there any more questions? I think we're done with. There's no questions that I can
No,
see.
I think we're all good to wrap up. Thank you, James.
Okay, super. Thank you. Okay, thank you for those questions. Hopefully those were useful. If you do have any more questions, I'm sure you can get in touch in due course. So the course assessment quiz. Yeah, almost there. You're almost home and dry. You've done the 6 modules. You've attended today's session as a 7th module. And then the final piece is the assessment quiz, made up of 33 questions. What we're going to do after this session is send you an email with a link to that. It's also on the Supply Chain School's website in the same place that you had the 6 modules. So you just need to log in again as a member. You've obviously got your registration and membership already. It should take you about 30 to 45 minutes. It's a variety of different questions that go across all of the 6 modules that we've discussed today. So roughly 5 or 6 questions for each module. All of the answers can be found in the course materials. So we're not going to give you any trick questions and you have to go off and do some extra research. It's all stuff that you've learned and that we've provided you already. As I mentioned earlier on, there's a pass rate of 80%, which is pretty reasonable. You can take the quiz as many times as you like. If you go through it and you're not quite there, go back, check the modules again where you are lacking some information, and then resit the quiz. And then at the end, when you do pass, you'll be able to see which questions you got wrong. So it's a fairly transparent process. When you've gone through that and passed, you'll get a certificate, which will be uploaded to your membership area in the Supply Chain School. And that demonstrates that you've not only undertaken the course, but that you've passed the course as well. So you can use that. And this is something that is transferable because it's your membership in the Supply Chain School, and you can take that wherever you might be working or whatever project you might be working on. So it's there. It's a transferable, permanent qualification. Cool. So there we are. We're pretty much done with today's session, a few minutes early, which is always nice. Please do provide your feedback as I asked at the top of the session. The link is in the chat box. I think Lucinda provided it earlier. So it's the very first message in the chat box. Just click on that, 3 or 4 minutes, and give us that feedback. That'd be really great. Just one final question has popped in about follow-up training. I think Lucinda's busily typing. I'll talk as well. There will be follow-up training that's in development. We're focusing very much now on the foundational course, but there are plans for a more developed practitioner level in due course. So we'd like to keep in touch with you basically about what that is and what it looks like. So you can make that natural progression. What we've covered, I don't think I need to recap that very much with you. So thank you very much for your time. I hope that was useful. Do look out for the email that will come from my colleague Lucy from the Supply Chain School that will give you the instructions on where the assessment quiz is and how to get through that. There'll also be a question to you in terms of GDPR about sharing your details so that we can contact you in future. Please do look at that. For those of you who don't come under GDPR regulations and you're thinking, James, what do those 4 letters mean? Don't worry, it's a thing you don't need to get into, thankfully. But for those of you in the European Union, you will be aware of GDPR. Thank you for your time. and we'll see you in due course. Take care. Bye for now.